So today we will talk about the humanized and medical AIs. The two parts are closely related. So I put it together. We talk about the controversial challenges and opportunities through discussion of controversies, how we can enlighten ourselves in AI research. Let me see how, okay. So the humanized AI looks like, think like, and behave like a human. Is really a life companion. A medical AI is narrow AI involved application of AI technology in drug development and healthcare to improve our quality of life or patient's experience. How to dealing with, we will talk about how to dealing with the fundamental issues, the philosophical issues such as self-awareness, creativity, language understanding, and we will discuss the principles that serve the backbone as the backbone of AI method, and we will discuss the main approach to humanized AI and medical AI. We will discuss why we recommend a small data approach at this time instead of a bigger data approach in precision medicine, and how we use similarity principle we are going to discuss to develop a machine learning method and apply it to the clinical trial as an example. So the AI we usually classify as narrow AI or weak AI. And then we have AI, artificial general AI, we call AGI, which is really broad collection of narrow AI or integration of narrow AI technologies. Human level AI is really have the general ability like a human, but the purpose is used for serving human being. Humanized AI, what I mean here is really a machine-raised human being, a life companion, not a digital servings. Because as a child, if we raise a child, we treat them as human beings, so they become a human being when they grow up. The same way, if we want to machine behave like a human, we need to treat them as a human. One aspect I want to mention is the AI and the human is really a two-way interaction. So we design AI, and AI, on the other hand, influence back to on us. And there are a few ideas on my way to AI. The first, AI product I made is called WinSARS. That's in 1995, which is really automatically generated SAS code based on the scaling the tables from the analysis plan for clinical trial. If you're familiar with the clinical trial, you probably know. When we do the analysis, present the clinical trial, we have a scaling the table, the template, the table template for SAS program to do. So here, the purpose is just use based on the stitching specify the scaling table, and you click a button, the program, SAS program will automatically generate. So this is the computer program that can generate the program automatically. And then after that, I have several ideas, some success, some not a success, like employee review generator, say, well, how we can generate the employee review, annual review draft, and from the draft, we can work on the draft of the final deliver the employer review, annual review. Of course, that's a dumb idea. And then I have the idea to generate the medical record review that help the physician to detect the signal. It's really the text review. It take a lot of time for physician and that's costly. So in the clinical trial, so we say, how can we develop an interactive medical review. And that this product is really similar to now you see in the Google search. When you search it, they have a highlighted text and the text around the search words. And then from that information, you can do in further research. And that's the idea, the similar idea when I do the trying to create an interactive medical review for safety signal detection. And it's not successful because the medical terms is evolve every day, basically online, and the different spellings, a lot of misspellings. I try to use the online dictionary to download automatically, and the check spelling just is too much. You cannot do it. Okay, and later on, I have idea to use reinforcement learning for clinical development program that I indicate in my book. And the next three things, AI, WorldNet, simulated-based machine learning, and humanized AI, I will talk about in later in this session. So the first question I have is, what's the purpose we develop AI? Well, the simple answer is we want to help people live happier and longer. But happiness is really related to many things: health, prosperity, social status, individual expectations, or the individual traits, whether you are optimistic or pessimistic attitude towards life, or also related to the having hope, dream, feeling empowerment, have a choice. But the key question here is, will the AI technology bring us happiness? Is it depend? The answer is depend how we proceed with the AI research. In the past, we hope that technology innovation bring more leisure times and less work to us. The problem is when the time we use has been saved through the innovation has been used work harder and longer and more challenging tasks. So that's not the purpose of technology innovation or AI. So we promote work more efficiently every day and doing how can do multitasking. When I even drive, when we driving the car, we say, how can I take a phone call or join the conference when I'm driving? That's the same multitasking, more efficient, but eventually make us become a slave of innovation. So how can we avoid that? So I think one way is we want to make AI as a provider life companions and avoid that weaponized and or using AI cause the social polarization. There are 4 waves in AI research, and Diaper proposed 3. I think I add one more. The first one is really the hand draft, the logic-based programming that very traditional before OOP, the object-oriented programming. Then second one at the current stage is really they call it statistical machine learning, is exemplified by the deep learning neural network. This great success in our image recognition have broader applications. That was second wave. And the next wave, suppose that contextual adaptations, because we think the dynamic is changing, the environment dynamic is dynamic, and the novelty is there. Yeah, every day we have a novelty that every 2 things are different. No thing are exactly the same. So we have to deal in the novelties And that kind of contextual, the meaning of your sentence, you have to put it in context. The action, you have to put it in the context to understand it. So that's the idea of contextual adaptations. And the fourth wave, we just called humanized AI, will be a machine-raised human. It's really like growing from baby with minimal inherited knowledge, no building any language. Everything's learning from simple to complex through recursive recognition mechanism. One of the things we, the most fundamental things people say, well, humans have a free will, AI don't have a free will, but things not that simple. It's controversial. The free Williams think that every choice we made is by free will. Without free will, there is no normality, morality, no right or wrong, no good or bad, no creativities. But the causality determinism, that don't think so, say everything is determined by the previous things. Everything have a cause, and cause have a cause. So that really everything is determined. Like if we know current situation, then we can predict next millisecond away, right? And then we just predict little by little, we can predict everything. If we know the natural law and we know all the factors, the current factors, in principle, we can determine that. Only we don't know. It's determined, but we don't know. And the answer to say there are no morality. Yes, we have the morality that the committed crime is not a choice. Likewise, punish crime is not a choice either. So it's not to say we make a decision or punishing, not punish. It's not a choice. Look at our choice. It's just an illusion. So I think that's probably very philosophical. The one of the, I think is strong argument that if there is a free will and everything else is have a cause, so everything is determined by the scientific laws, and the only thing is free will, is make the choice. So now everything, why we say everything, we can answer say because of free will. Okay, so that's also not very interesting if both free wisdom and the causal determinism. The next question is, can AI supersede the human being? Well, that's probably not a question. Why? Because we replace malfunctioning organs with healthy one, and we do exercise, we improve our health, and we learn knowledges from school, and we try to erase the bad memories with medical, without medical assistance. But all those things change our mind, our information in our brain, our bodies. So at what point that me is still not me, we didn't lose, we are started to lose the identity in the process. Say again?
Mark, please keep going. I have muted the audience.
Oh, okay. So the question is, if I loaded the knowledge electronically some way, when AI developed into your brain without learning, and you certainly jump from age 1 to age 20, would you be happy knowledge-wise, right? Probably you say, no, I want to keep the experience. So one of the issue we discussed in humanized AI, also called meta recognition, that thinking about the thinking. or self-awareness, consciousness. That's all related to this meta recognition. And we are not philosophically talking about whether they can or cannot. We say how we can do it. Actually, as long as we're using the recursive learning, recursive network, we can do it, right? If you think that we want to understand the whole world and include ourselves, so basically we say our brain understand the whole world and our brain itself, you just like a big vial, you put it into the small vial, that's impossible. So the solution is you simplify it, you put similar things together and make scientific laws, and then break a piece together, put in your brain, and then when needed, you resample it. Okay, so the self-awareness or consciousness is really like the diagram I put on the left. Is there are several me's, right? I think myself inside and think of even inside myself, right? So I think about thinking about thinking. That's the using the recursive network we can build. Without further, I think the time limit we cannot each topic we cannot dive in too much. So the next one is the AI embodiment. Embodiment is important, of course. We have the sensory organs, so we can interact, we can perceive the world, we can interact with the world. But how much embodiment is necessary in order to human being become a human being or machine become a human being? That's is controversial, right? Is a blind person, we still think is a person. Deaf person, we still think is a person. And deaf blind person, we still think is a person. So the intelligence level is not determining whether you are a human being or not a human being. So Helen Keller, you know that he is deaf blind, but he is well-known American author, political activist, and a lecturer, and he had got a bachelor's degree. So it's amazing. The other fundamental questions to be asked, whether AI can make discovery or invention. So what's the discovery? If something that exists outside our mind, then we call the discovery. Is the things it does not exist outside our mind, then we call it invention. Okay, so the question is that in principle, a random text generator that's very simple to make, everyone can make it, can generate an exact text like a Darwin theory. Then if the text generation occurred before Darwin, would it imply that the AI discovered the theory? Or is the discoverer is the AI or human reader? Should the text be interpreted differently because it's AI generated, not a Darwin or not a human being? So it's really a very controversial. What do you mean, the discovery or invention, the creativity we're talking about? Even more controversial, we say, can AI have a wisdom of understanding? So what really the understanding means? That's one of the project I did, or the pattern I mentioned in the very beginning. When we trying to figure out the meaning or the connotation of understanding, when we try to explain the words, let's say a concept that's intelligent. So what do you mean intelligent? You may say, oh, a lot of knowledge. What do you mean a lot of knowledge? And you say knowledge is a power, or knowledge is, you know, a lot of things you can do. Whatever you explain, you words by words, concept by concept, I continue ask, and eventually you will exhaust the words you use, and you use a circular definition. I looked at online dictionary, basically the intelligent eventually go back to intelligent, okay? So if you explain concept doing the circular definition, so the concept, the knowledge is actually is a concept mapping, and the concept is whether use English, use Chinese or other language is not important, or some other thing, it doesn't matter. The matter, what is matter is that the topological structure of the network, if you link those words together because of they are explained by the other words, so we link built the network, and that network is each individual different depending on your explain. And that was actually my daughter, when she in high school, she's interested to take this project and collect the data from her school. And we found that the topological structure of the network is significantly related to the IQ, whether left brain IQ or right brain IQ, but we didn't find significant connections between the personality and the topological network. And that probably because the network too simple when we ask the question, we only take a 30 minutes limit to ask the questions. If we build more, we pick the words, not start with intelligent, we may pick something love, could be have the correlations. So the key point is that the meaning of understanding is not as we thought, and the understanding can be digitalized, can be numerized. So that can use the AI to do the analysis. Okay, I think I need to keep going. So how do we dealing with the imitation and analogy and creativity? Actually, the AI can do the creativity, and as long as we all dealing with the same on the same umbrella called similarity. When there are a lot of similarity, we are called the imitation. When have some novelty there, we're doing the analogy, knowledge from one field bring to another field, then we call it creativity. There's some similarity. So it's really is the how dealing with similarity. Okay. And that actually we can do it. We can the architecture to build based on the similarity, then can create whether imitation or creativity, and that is the choice of the AI. So in order to build the AI, we need some principles that can be simplified and not without any principle and build everything don't have the integrity. So this principle is abstract and broad applications. Method is concrete, very specific to the problem we want to solve. The principle, not a direct solve problem, but use it for development methodology to solve the problems, and is really the source of creativity and make the method a coherence. And the principle we used for building the AI is the similarity, parsimony, and associated first, and the principle of factor oscillations. We will just talk about similarity principles in detail later on in the medical AI, and leave other in the back of the slide, or you may refer to my books. So regarding the approach, the existing approach to the humanized AI there are several. One is the very early in 1960s, the symbolism that use logical program that is the first wave. And the second wave, that's the connectionism, that's basically say is the neural network that make the AI work. So everything based on a neural network. And network is very difficult to explain, use our high level concept. And we cannot make sure the neural network make is human being, not a monkey, is very challenging. Behaviorism is really goal-driven approach, is efficient, but very difficult to lay out the determined goals in different time. Excuse me. A constructivism is, in simple words, is represented by the reinforcement learning, and reinforcement learning is very inefficient. You can learn everything, basically everything you can through reinforcement learning, but so slow that's impossible for take a human being the whole life learn even very simple task. The other one is called syntheticalism that I propose, that combine with the behaviorism and constructivism together, which is flexible, also efficient, and use the recursive structure to do that. We say the world can be classified the multifaceted, the actual world, and what we sensed, and what we can simplify in our brains. And with that structure is the humanized architecture can build on. This the kind of sketch of the architecture of the humanized brain. And here I want to emphasize that you need attention mechanism. So there are so many things you need to focus on when the attention, how the attention work, what the object you are trying to pay attention. Adaptive method is one, adaptive reinforcement learning. Recursive is from simple to complex concept. We don't have time to go through all details. And the way I recommend is using a small data approach, not a big data approach. Big data have achieved a lot of success in narrow AIs to solve particular problems, and even can unblind the data. And if you work on the clinical trial, you say the data is blinded. We don't know the patient's treatment, what the patient treatment that they got. But if you put the data all together, it's huge data, and you will see the two normal distribution in the treatment group and in the placebo group, they have a different means. So the two normal distribution put together, you will become the mixed normal distribution. And when the difference is big or the data is increased, then you see the two peaks start to separate, and we can see the treatment difference even without unblinded treatment. Okay, but why we're using a small data approach for our clinical trial? Because clinical trial data is small. We don't have a huge data, especially for rare disease and precision medicine. Second is human child don't have a big data inherited from their parents, but instead they have an incredible learning skill. The mechanism is simple, but very flexible, very powerful learning mechanism for them to learn. Whether you put it in English speak environment, they will learn English. You put the Chinese learning environment, they will learn Chinese. So no building any language, virtually no data inherited from their parents. That's why we say we need using a small data approach. So there are many challenges in evolution in the learning models. One of it is regarding the how to choose the optimal decision. Say if you have a dice, 4 dice, that's the non-transition F1 dice. That's the 6th phase have 4, 4, 4, 0, 0, and the die B is 3, 3, all threes, and all the 4 dice have different phase values. And when you using the die to bet, let's say you using A, I using B, and A will win B, and the B will win C, C will win D, but the D will win A. So that's all the things. They are all equivalent. Not to say one is better than the other. But if we don't know C and D exist, we say, oh, A is better than B. A can present a social system or product, and we think it's one social system is better than the other without knowing other possible systems, but these 2 systems is the same. So that's going to make the optimal choice is very difficult to make. We think we make a right decision, but actually don't. We think that one social system is better than other system, but actually the same. And also there are the difficulties in learning regarding the causality. The data show that those people have high achievement, live longer. And so we conclude that studying hard and knowledge can improve your brain and prolong your life, but actually it's not, because survival longer enough is the precondition that you have achievement, right? If you don't have live for 1 year, how can you make achievement? You have no time to achieve. So you have to be live longer to have a great achievement. So it could actually, that's called survival bias that in our clinical trial analysis, probably a lot of people familiar with. The other thing is that its response model is very difficult to build. There's a multi-faceted decision makings. For example, that the COVID case, we say how we determine the outcome. We say that's the outcome, and we heard so much news from the news that the COVID caused many deaths. But on the other hand, the COVID could reduce the deaths and prolong life in the near future. Why? Because the weaker, the sicker, the older patient had died earlier. So in the next several years, we see the life expectancy is extended because those people have relatively healthy. I'm not saying the COVID is a good thing, but it's really when we evaluate the impact of COVID, we should not just look at the current deaths, but the impact, what the future impact is. So that's why the decision is difficult for AI. The second one is that because the false positive rate in the test screening, and some countries use zero tolerance policy, and that we may actually fight against the false positive case. So if you keep screening, then you keep find false positive, and false positive, you do quarantine, and the quarantine, you more scanning. Scanning, you have more false positive. You should continue to fight and never end. So unless the zero tolerance policy, the zero is really means something that the number is slightly above the false positive rate, then that may work. So the learning and the response is go hand by hand. Learning is learning from the response outcome and the responding according to knowledge we learn. Okay, so now we can move to the second part. I have to do a little bit quick, okay? So as most people you know that the type of machine learning is include the five type the supervised learning, unsupervised learning, reinforcement learning, swarm intelligence, and evolutionary learnings. I don't have time to go details, but definitely happy to discuss more, or you may be looking more information from our book. I put this all together like narrow AI method, and using the tree diagram is to help people who are new to the AI and maybe can get confused which method belong to which group. So I put this different particular methodology belong to which, whether supervised learning, reinforcement, and unsupervised learning. I put this together diagram so you easier to know, wouldn't get confused. Regarding the medical use, the AI in medical use, I use in medical science, then I put all this together to see which method has been used in which area of drug discovery and development. And all those applications have a reference in my book, the last chapter, the application of AI in medicine. So you can look at this. If you want to look at the further information, you can. Okay. So now we are going to discuss how we're using the similarity principles to develop machine learning and apply it to clinical trial. But before that, we discuss some of the motivations. I really need to go fast. So here is the paradox. We know that when you have drug A and the drug B, and when male, female, we see which drug is better based on the good response. And from the total population, we said the drug B is better. Drug A is not as good as B, but from each category, we see is drug A is better than drug B. So which drug we're taking, how we do that? If we further divide the populations, whether drug A good or drug B good is opposite. So that means if we're running a trial with female-male combination, the conclusion we get, and or with by two trials, gender-specific two trials, that will be very different conclusions we will get. So which one is good method? Here are another examples. We don't have time to go through. And we say, well, we prefer run a bigger trial with male, female, and do an adjustment. But that adjustment is still very controversial. We don't have time to discuss this. Basically, you have independent variable and correlated depend on which variable you put in, and those interpretation of the effect of other factor could be very arbitrary, subjective. Okay, so the covariance adjustment is not viable solution. Even you have a bigger data, it's really arbitrary. So how we solve this problem? We say use the similarity principles. The principles say that the similar things or similar individuals will behave similarly, and the more similar they are more similar they behave. So that's what we use in our daily life and in scientific research. We use it subconsciously. For example, we say we may use the drug in the clinical stage, and we use it move to human being. Why we need the drug test in the preclinical in animal? Because we say animal is similar to human being. So if safe in animal, then we can use in test in human. So that's the philosophy, right? There are anything why we can take the drug, because is take the drug has already been tested in the human being. So the market drug, we can take it because we, even I'm not in the clinical trial, but my disease is similar to the people in the clinical trial, so I can take it. The response is better to be similar. So that is saying the response is based on the similarity score Sij, and weighted by the other people's response. Using that, we have two approaches. One is we say with statistical model, where response equal to a model F and have independent variable X, and we have parameter A. And the other approach is similarity approach, is that we try to look at the relationship between response, the future patient's response, and using the current the patient response in the clinical trial, and based using the characteristic of the similarity between the two patients, not the two, the patients between the future patient and the current patients in the clinical trial, and to do the prediction. Okay, so this is more intuitive. We're using everything in our daily life. We're using that similarity principle. The question is how we can determine the similarities, whether we have age have a slightly different, we have weight different, we have height different, we raise maybe similar, maybe different. How we can measure the similarity score? How important each factors, and that we're using the machine learning to determine the scaling factor that the similarity scores for each factors. So this is basically the similarity score is a distance function, and distance function is really the attribute the difference between the two patients, and using a scaling factor, whether this is weight scaling factor or age scaling factor, we put a scaling factor. And how to determine this scaling factor, we do see similarity. We're using machine learning to determine it. And we have regulatory regularization approach and grading the algorithm, gradient method for the algorithm. Here, the simulation result is really the data show that the method of our machine learning is much better. So if this is the clinical trial when we run with the result, you say have different training size of training set with the linear model, the optimal linear model, and rigid regression. We see this method that the similarity-based machine learning is much better in this case. So here, I think I have conclusion that the humanized AI, AI is trying to make the people happy longer instead of making people work harder and longer. And the humanized machine raised human is not a digital machine. This is a slave for humans. We need to raise them responsibly, basically train them responsibly. Regarding the architecture, I think the simple but very flexible cognitive system with minimal inherited data with no built-in language can work, and should be the way to go. I'm working on my book, probably finish end of this year, about all the details, architecture, algorithm to build the humanized AI. I have the prototyping in very earlier, in probably 15 years ago, that work, the machine, the agent can learn the language, simple language themselves without teaching without building in any English or Chinese, that works. So I'm now working on the prototyping for more general learning, more complex concepts. We remember the interaction is two-way. We built the AI, and AI also influence our behavior. And it's a mutual acceptance whether we accept the human machine as a human being, and they also have the right to accept us as the same type. I think that a lot of people, there are a lot of social, societal problems, and one of the aging of the society, and the AI as a companion is really important. As is coming very soon. You see a lot of robot looks very like a human, very simple conversations with human. That's already there. Not very expensive. You probably $1,000 to $2,000 you can buy it. In the aspect of medical AI, that has been used for drug development, discovery and development, health management, improve quality of life. I suggest a small data approach for precision methods and predict on focus on predictions instead of type 1 error. I think the way it's work is a challenge. There's a practical problems how we push AI in clinical trials. The difficulty because the regulatory authority still the rule is based on type 1 error control. But we should have to mobilize that the whole industry and with the regulatory using smaller clinical trial combined with the real life experience plus enhance the pharmacovigilance and adaptive marketing authorization. That can work very well. And last one is we need to reduce intentionally or unintentionally bad use of AI. We see a lot of AI using in the news, in social mediums that is really make the society more polarized. And we need to avoid that and avoid the weaponized AI. I think I'm sorry I have to run through so many topics. That's just an introduction. So if anything future that topic particularly interested to you, I definitely can do another talk or we can talk through emails. The other things I have backup a slide for, okay, have an acknowledgement for the 4 peoples. Susan is my student for PhD student work on the AI. She just graduated a year ago. Bingming is from Vertex, and the 2 professors, Robert and Michael from Boston University. All back slides here and the reference in the end if you particularly interested in the details. Okay, I stop here. Sorry, leave just a few minutes for questions.
Thank you. Thank you, Mark, for a very educating seminar. I personally very much enjoyed it. I'm sure the audience have enjoyed it. And I want to ask everybody, if you have questions, feel free to post in the chat. I noticed Jing has mentioned AlphaGo, which is a great example of AI interactions. So I'll start with throwing you a question, Mark, if you don't mind. I really like how you're leveraging, cystic fibrosis, how you're leveraging, your as an example. So could you very quickly on a high level comment? I know you have, years experience, working with FDA as well, dealing with a lot of the regulations, as you mentioned. So from a medical perspective, like, what do you think is, the biggest challenge it is dealing with, for example, FDA, for example, if we have an AI medical product, it could be a diagnostic, could be, how we approach small clinical trial data. How do you think an AI product dealing with FDA, what is the biggest challenge there? AI is constantly, we're learning new things, adding new models, and later on AI is being more and more intelligent, but your product is constantly evolving. So how would you approach the challenge, and how would you think it's a major challenge is when you have an evolving AI product dealing with FDA, and how do you think is the best approach to overcome that on a very high level?
Yeah, I think the approach will probably take similar. Remember when 20 years ago, when we work on the adapt design, if the regulator say you guys are too fast, we don't have experience that we cannot move that fast. You may start in early clinical trials and get some experience. So we feel comfortable to accept those adapt designs. The same thing, when we're doing that, we are not working on immediately on the phase 3 trial for approval, but we looking at the early trials, how we can using the early trial information predict the later phase, how we can inform the later phase design. The AI can inform you, say, which population will be good. If you go in this population, how much response you get. And we see how the response group is different between different characteristics, and we can target moving to those populations and predict, even say the whole population is not very beneficial for the drug, but is really, say, any subpopulation we can predict better. And that kind of force, I think, is need to really move to, say, the prediction is ultimate goal. We want to predict the current drug in the clinical trial, how predict the future patients benefit on the drug. So I think it's instead of using type 1 error control, that's you try getting huge, because the improvement getting smaller and smaller, the margin getting smaller for the benefit, and your sample size getting huge. No way you can use using a type 1 error control. So these things we can use early trial predicted in the later phase, or using the in the later trial, the first half of the data in the phase 3 trial, and predict the final result in the trial. I think that started to learn from that, and that regulatory people feel comfortable. So we kind of start with early and predict later and make that work. And as an industry, we also need to learn some experience with the real data.
Thank you, Mark, for on a high level concluding that. I do have another follow-up question, but I'm happy to chat offline. I want to talk about computational biology in general, but I do notice we're running out of time, and folks are DM me asking for slide decks, asking for questions. Probably they're going to follow up later. I'm sorry we're running out of time. Let's try to get back to one more question being posted in the chat box about the third wave of AI, contextual adaptation. Mark, could you share with us a little bit more on that side? What kind of technologies are behind the third wave, if not neural network or reinforcement learning? So that's basic question. So what can you share with us? What are the available technologies behind the third wave of AI contextual adaptation on top of neural network and reinforcement learning?
I don't think there are much. People are also using Bayesian decision or reasoning network to do that. Anything I think is anything I think is they are not, basically the methodology you mentioned about neural network and reinforcement is probably the main tuning approach. The other is not too much. The way I use is really use the recursive learning. It's really built on the simple concept, as I show in the I network, that usually you use a simple concept you learn, and then learning the more complicated network through the interactions, like the real human child. You learn very simple concept, and then you use the concept to explain the more complicated concept. Using that the progressive learning recursive network to do the work, not just the simple deep learning neural network that's kind of not recursive. We're using the recursive ones. So it's a complicated, but it's the concept is simple. You're just using each one you recursive, and then using that recursive, you also have the self awareness, consciousness. So that kind of what you can learn to understand the content. And everything, if you really to build content adaptation, is really you put it into the environment. Not reinforcement learning current have is really too slow. That basically can learn everything, but it's too slow, very difficult to put it actually as humanized AI. But if you, or the third wave is very difficult. But the recursive is really the way to go to understand the contextual. I don't see any particular methodology that focus the contextual work very useful.
Gotcha.
Except the popular ones you mentioned too.